Okay. Um, Good day, everyone. In this video, we'll be discussing the last na gyud na part sa to ang integration techniques na part. Okay. So we're dealing with the miscellaneous substitution na technique, pero trigo functions yung atong i-conquer na atong i-focus. Pa. First, in the first part sa atong discussion katong sa miscellaneous substitutions, we were dealing with functions that are algebraic in nature. Okay? Particularly functions na involve og mga polynomials in which ang mga powers niya kay mga fractional, di ba? We're dealing with square roots o cube roots. Okay? But in this case, we'll be dealing with functions ay integration of sa mga functions in which nasa mga trigo, okay, mga sine ug cosines, okay. Basically, I'm saying sines and cosines, although na siya uban naga-contain og mga tangent, pero we can basically break them down in terms of its sines and cosines na lang kay para mas simple siya, mas universal ang atong idea, okay. But anyway, that is ang itsura sa atong mga integrals na ginadil karon. Now for miscellaneous substitution, before ta maka-delve ana, gusto ko mag-derive sa ug isa lang gid sa klaseng substitution, okay? Everything will be can be expressed sa kanina klaseng substitution. So dili siya ingon nga magkwanta kanang maghimo tag kanang mag-define tag kanang dami na function, okay? Tanan siya maagi ani, tanan siya magamitan ani. Tanan cases na tong gamiton na integral magamitan siya ani, okay? So anyway, muna siyang mag-derive ko dani, isa lang siya kakuan system of substitutions. We will be using them sa atong tanan integrals man encounter karon. Now let's try deriving some equations ako, no, be. Say natin yun ani, need to find representatives for sine x o cosine, ba? Okay, you have to reduce everything in terms sa sine o cosine. Now klaro ba siya? Maggamay wrong on. Okay. Let's try first with sine daw. Sine x. As you can see diri, naman ko codigs na lang. Sige na lang, okay? That is 2 sine. Gusto ko mag-imog relationship between double o half angle. So, kaya siya diri, if this is double, if kanya tong double, 2x man na siya, so kanya siya may muna siya og x over 2. Likewise, kining cosine pod nato will be x over 2. Ba? So, we have something like this. Now, akong gusto mo na ni saya hadayon, ako siya i-express terms sa ingon ani. Terms of tangent x over 2, okay? Let's try to express everything in terms of tangent of x over 2. Ako lang siya i-label din as z, okay, para nalang take one din gamay kanang labeling lang ana saya gamay. Anyway, we have something like this, diba? So ako ni siyang mag-multiply kog something ani saya ha. Pwede na ako siya ma-manipulate na ako, diba? We have sine x. Gusto na ko siya express tanan in terms of tangent. Ako'y gusto i-multiply ani siya. Gusto na ako cosine x over 2. Ako gyapon siya divide by cosine x over 2. Diba? Wako'y doubtan gibuhat. Because ang quality sa equation, it still remains the same. Okay? Nagdugang ko niya kung ano siyang i-divide. Ba? Wala nang giusab ang quality sa equation. Only its form. Now, sa nga na case diri, I can just take 2 dahil lang sa gawas. Kani siyang sign din eh. I'll pair this sign with kani siyang kwan din eh. Cosine sa ubos. So we have something like this, and then kani siyang cosine, kani siya kaniya may pares, so cosine squared na siya. Okay, so we have something like this, di ba? kani siya diri, it's really recognizable na dayon na tangent x is equal to kuan. Kini ba? Sine cos, same angle. So, this effectively becomes tangent x over 2. Okay? Nya, kani sa din diri, cosine squared, that effectively becomes unsa? 1 over secant squared x over 2. So, ako siya isulat na sa din. So, 2 times tangent x over 2 multiplied by 1 over secant squared x over 2. Okay? So, natin nga niya klaseng ko din, expression ni result. Now, I would like to recall daw ko, no, let's talk about the Pythagorean theorem. Pythagorean theorem, Pythagorean identity. 1 is equal to sine squared x plus cosine squared x, di ba? I think muna siya itong Pythagorean identity. I would like to verify lang sa via calculator. Okay, sakto. Okay, so we have this Pythagorean identity. If I divide this, I divide everything though by cosine, I will have unsa secant squared x is equal to tangent squared x plus 1. So I have something like this na dayon, ba? Now, we say then diri, when I talk about secant squared in terms of tangent, so nga na yung form. Likewise, ako din siya yan na din diri, secant squared is unsa ultimately equal to tangent x over 2 plus 1, ba? Kaya siya entire na to na expression. So, ako na siyang i-rearrange na po dayon. I will have tangent kanisya over 2 divided by, so man siya dire, tangent squared x over 2 plus 1. Now, I equate this with unsa sine x. Okay? Wala pa. Sorry. Excited ako. So, natay nga ni na klaseng kung itsura. Ba? So, we already know that tangent is equal to unsa kani. This is the format we want. Okay? In terms of z. Kani siya din diri becomes z. And this, kani sa siya, this becomes z squared. So, this becomes unsa na po din? 2z and divided by unsa z squared plus 1. Now, I have the form of sine x in terms of z, 2z z squared plus 1. In which z is defined to be tangent x over 2. Okay? Okay, let's continue. So we have z, we have sine, ang atong wala pa sa din kay si cosine, ba? So, let's try to derive an expression for cosine daw. Double angle ano yun na kuan theorem states that cosine x is equal to cosine squared x over 2 cosine na ba? Minus sine x over 2, di ba? Squared yapon siya. Ito. So, I have something like this. Now, ako ano siyang kanon din strike clearing this up daw ko, no? We have something like this. Kadot lang ang ba? Okay. Sine squared kuan. Gusto na ko ni siya kuanon sa himuon sa nato sa tanan everything in terms of cost. Tsada man na siya na strategy. Unsa kay itong kuan niya? 1 is equal to sine squared x plus sine squared x, di ba? If that's the case, Pythagorean identity, we use that. So I have cosine 2 minus sine. Sine can be kuan. From that is equal to unsa 1 minus cosine squared x over 2 ba? You just need to transpose this payon do sa left hand side niya na naka-expression din for sine squared x. Okay, so singa na case in diri, I continue on. I shall have this 1 plus cosine squared x over 2 yan na. So ako na siya padayon dayon. Cosine can be combined. Cosine squared x over 2 minus 1. Now, cosine in terms of second, that is unsa inverse ana niya. So I could say din diri 2 times 1 over second squared na siya ba? But you still have to realize sad siguro na if ako na siya divide everything by kuan, I can say second squared x is equal to tangent squared x plus 1 ba? Divide everything by cos. Kana ko makuha na expression. So with that in mind, ako din siya ikuha na sa diri. I express this in terms of tangent. So this is 1 minus sama na siya tangent squared by the Pythagorean identity of secant and tangents. So nga na siya plus 1 minus 1 ba? So we have something like this. Now this is actually equal to unsa na sad b? Z. In terms of z, this is z squared. Okay, so ako na siya change din diri to ako siya reabsorb sa tong fraction, becomes unsa z squared plus 1 minus 1. So something like this. Now I go beyond na sa din dayon. I continue on. So this becomes unsa na sad 2 over sa man siya be 2 over z squared plus 1 kani siya diri minus 1 man siya, minus 1 times the denominator which is z squared plus 1. Okay, so 2 minus kani siya diri tanan, that should be equal to unsa 2 minus z squared minus 1. So this immediately becomes unsa na pod 1 minus z squared over z squared plus 1. So by that na idea, I can express cosine x in terms of z 1 minus z squared 1 plus z squared, or pwede sad sa mga din na z squared plus 1. Okay, I hope na kuha na ninyo. Just try to rewatch the video if you get confused sa derivation. Rewatch lang din. Okay, so muna siya cosine in terms of z, in which z is equal to tangent x over 2. Okay, so nanananta isan lang ka concern din be dapat ito ako sa isulat be si cosine x is equal to 1 minus z squared plus 1 ba? Okay, we have sine x, we have cosine x. The only thing na wala pa sa tuwa diri karon kay siyempre nagkuan man ta, we're dealing with substitutions diri na natin mga substitution para sa mga functions ba? Sin x and cosine x can deal with almost any trigo function. Aton lang ko lang diri kan differential na lang, diba? Which is dx. We need to derive an expression of dx in terms of tangent x. Yeah, in terms of z na din ultimately. Okay? So, sa nga na case, I would like to borrow the very first equation natong gikuan din which is equal to this. Ba? z is equal to tangent x over 2. We start everything by this. So, ako na siyang ikuan diri, differentiate na ko ni siya, I will have dz. And differential of tangent with respect sa x, that is, unsa, 2 times, unsa man na siya, secant squared x over 2 times dx. Diba? Or, di siya over 2 times 1/2. Okay? Kaya ang derivative man na sa sulod niya, siya ako ikuan din eh. This is, kani siya, the secant squared niya, times ang derivative sa angle niya, which is equal to sa dx over 2. Ba? That is the derivative sa angle. So, we have something like this. Now, ako siyang i-transpose din ito because I will have 2 dz divided by secant squared x over 2. Ba? So, this is what we define as dx. But it's, dili man tadi arataman, so ako siya rearrange di gamay. You have 2 dz divided by secant squared x over 2, ba? So, Pythagorean identity states that secant squared x is equal to 1 plus tangent squared x, ba? Pythagorean identity. So, by that idea, I can say din rin na this is tangent squared x over 2 plus 1, ba? Pwede naman siya interchange. That's basically the same ang meaning ana niya. Now, I will rewrite this. I will have 2 dz divided by tangent squared x over 2 plus 1, ba? Tangent squared x over 2 plus 1, that is equal to z squared. Okay? Z squared. Kani siya. So, ako siya i-replace din diri. This becomes 2 dz over z squared plus 1. Now, kung ano siyang i-rearrange lang din diri, just to tidy things up a bit, we can say din dara that the expression for dx is actually equal to this. Thus completing our lineup for substitutions. Okay? So, idea ni saya, whenever we face problems na nag-involve ng mga trigo functions in which medyo unusual ang iyang plastada, gamit din ka ni diretso. Okay? Let's try solving some problems daw kuno just to see how it works.